All right, welcome to part 2 of lesson 6. We're going to take a little deeper dive into solving inequalities, in particular looking at how to solve and graph our two-step inequalities that have positive coefficients. And when an inequality has positive coefficients, meaning that the number in front of the variable is a positive number, really the steps to solving them are quite similar to the steps for solving equations. We're going to start with undoing any addition or subtraction with inverse operations, meaning we're going to get rid of that constant. Then we're going to undo with multiplication or division with another inverse operation, meaning we'll simplify that coefficient. Then we want to check. One difference is when we want to do a check here, we're specifically going to use a value other than the boundary point. So I will show you what that means. And lastly, we will be graphing our solution set. And with all of those graphs, we want to use at least 3 data points on our scale. Once again, I'll show you what all that means. All right, let's get started with simplifying that constant. Let's undo this addition. So we're going to subtract 3 from each side. You'll notice I didn't necessarily set up a T diagram here, but I still am going to line up my symbols, and I'm still going to show any algebraic move I do. I'm going to show it happening to both sides of my inequality. Okay, so that simplifies down to 1/2 of r is less than 3. And then I can multiply both sides by 2 to bust out that fraction. And we come up with our answer of r is all numbers less than 6. I'm going to write that down. Okay, so r is all numbers less than 6, not including 6. So for my check, I want to pick a number other than my boundary point. So right now my boundary point is 6. So I want to pick a number that is less. Let's try it with 5. I'm going to check when r equals 5. Okay, and then 1/2 of 5 is 2.5. And it is true that 5.5 is less than 6. So I know I did it correctly, and I can go ahead and graph it. So since my solution is all numbers less than 6, but not including 6, we need an open dot at our boundary point of 6. Throw a couple more pieces of data on there. So here is where 5 would live. Here is where 7 would live. And then you can either draw your data on the number line, or I like to pop it up above. So I would say my solution set is all numbers less than 6. Make sure you include that arrow at the end to show that it does indeed go on into negative infinity. All right, so Billy Bo Bob gets to go on vacation. And on vacation, he wants to buy a souvenir necklace with his name on it because he's hella cool. The jewelry maker charges a flat rate of $4 plus 75 cents per letter. Billy Bo Bob has saved $29 for souvenirs. He wants to know how many letters he can get on his necklace. So let's start with just writing down the stuff we know. And again, as I'm reading, I usually highlight all important data that we can use to make calculations. So our known information is that we know there's going to be a flat rate of $4. And that flat rate means that it's going to be $4 no matter how many letters on the necklace. We know that it's 75 cents per letter, and that Billy only has $29. So we need to decide what our variable represents, and that variable is going to, again, be the thing that changes, and that will affect the value of this necklace. The thing that changes here is how many letters he puts on his necklace. So I'm going to call it X and say that that is the number of letters on his necklace. Next, I'm going to ask you, what is the relationship? Basically, let's put into words what is going on here. And what's happening here is that he needs a necklace that is at most $29. It cannot be more than $29. It can equal $29 because he has that. So at most, he can spend $29. All right, so let's set up this inequality. We know that there's going to be $4 plus there's going to be 75 cents per letter. And we know that that has to be less than or equal to the amount of money that, that Billy has, which is 29. And then we can just start solving. I want you to pause this and try to solve it on your own. Come on back and see how you did. So I ended up with x has to be less than or can equal 33 1/3. So for our solution and what it means, we want to use the rule of rounding and just reason that we can't have a third of a bead or a letter on this necklace. So we're going to round down and say that Billy can afford at most 33 letters on his necklace. Oh, something weird happened here. Now, this might be a good time to do a check, or you can do a check after you graph. I prefer to do it before just in case I made a mistake so I don't have to redo my graph. So I'm going to go ahead and do my check. And let's see, I want to pick 1 this time, because 1 is a part of my solution set. All right, so replace my variable with 1, and it is true that $4.75 is less than or equal to 29, so I know I did it right. And I'm gonna go ahead and make my graph. So my boundary point of a true statement is x needs to be less than or equal to 33 1/3. We rounded that to 33, so I'm going to use 33 as my boundary. This can include 33. I can get 33 beads. I can get 33 1/3 beads if I really wanted to be rude and demand that the jewelry maker saw 1 in thirds. So close point, and then I can get all numbers less than 33. So why don't we just put 31 right here, 35 right here, and we are all set. Okay. Here's how you try it. Check it out, solve it, check it, graph it, and come on back and see how you did. Okay, my answer was x can be greater than or equal to -108. So since 0 is a part of my solution set, because that is indeed a larger value than -108, I'm going to check for when x equals 0. And indeedly, 2 is greater than or equal to -16, so I know I have the correct solution. So my boundary point is -108, and it's going to be a closed dot there because it can equal -108. I'm going to pop some more information on there. Here's -110, here's -106, and my answers are all things greater. Okay. Go ahead and grab those journal problems and give them a try. Let me know how I can help you. And remember, there is Khan Academy Extra Practice if you'd like to see some more examples. Good luck, guys.